The Manhattan Project is often hailed as one of humanity's most ambitious scientific endeavors. It gave birth to the atomic bomb, changing the course of history forever. But the story we've been told is incomplete. While figures like J. Robert Oppenheimer and Enrico Fermi have been immortalized as the heroes of this groundbreaking project, one of its key contributors, a Chinese-American woman named Chien-Shiung Wu, has been largely erased from the narrative. Chien-Shiung Wu was a physicist whose brilliance saved the Manhattan Project from failure, revolutionized nuclear physics, and shattered scientific conventions. Yet her name is missing from history books and even Hollywood's retelling of this monumental event. This is not just a story of scientific achievement. It's a story of resilience, brilliance, and overcoming systemic barriers. The remarkable journey of Chien-Shiung Wu. Early life. Breaking barriers in education. Born in 1912 in the small town of Liuhe, China, Chien-Shiung Wu's life began at a time when education for women was not just rare, it was revolutionary. Her father, Wu Zhongyi, defied societal norms by founding a school for girls, an act of rebellion against the entrenched patriarchy of the time. This bold decision changed Wu's life forever. With access to education, Wu's natural aptitude for learning flourished. Her early curiosity led her to excel in her studies, and she quickly developed a fascination for science, particularly physics. At National Central University in Nanjing, Wu was a star student, graduating at the top of her class with a degree in physics. But for her, this was just the beginning. Wu dreamed of studying with the best minds in the world, and in 1936, she made a life-changing decision to move to the United States with financial support from her uncle. A new chapter in America. When Wu arrived in the United States, she found herself at the University of California, Berkeley, an institution that was at the forefront of scientific discovery. There, she studied under renowned physicist Ernest Lawrence, the inventor of the cyclotron, and rubbed shoulders with legends like Robert Oppenheimer. Wu's talent quickly set her apart. Her groundbreaking research on beta decay and radioactive isotopes earned her a PhD in physics. Even among the most brilliant minds, Wu stood out, not just for her intellect but for her meticulous approach to research and experimentation. After earning her doctorate, Wu became a research assistant at Berkeley and later joined the faculty at Smith College and Princeton University. She shattered gender norms by becoming one of the first women to teach at these prestigious institutions. However, her biggest challenge and greatest contribution was yet to come. Saving the Manhattan Project. By 1944, the Manhattan Project was in full swing. The stakes were enormous, creating a weapon that could end World War II. But the project hit a major roadblock. The world's first nuclear reactor, designed to produce plutonium, kept shutting down. The cause of this mysterious failure was unknown, and the project faced potential disaster. In a moment of desperation, the team turned to Chien-Shiung Wu. Wu was tasked with diagnosing the problem, and her expertise in experimental physics proved invaluable. After rigorous investigation, she identified the culprit: xenon-135 poisoning. This rare isotope was absorbing neutrons at a rate that disrupted the chain reaction necessary for the reactor to function. Wu's diagnosis and proposed solution saved the project from collapse. Without her, the Manhattan Project might never have succeeded. But Wu's contributions didn't end there. She also played a key role in developing uranium enrichment techniques and solving isotope chain reaction problems. Oppenheimer himself reportedly acknowledged her expertise, saying, "Go invite Ms. Wu. She knows everything about the absorption cross-section of neutrons." Yet, despite her critical role, Wu's name was largely left out of the historical record. Revolutionizing physics. After the war, Wu continued her groundbreaking work. In 1956, physicists Tsung-Dao Lee and Chen-Ning Yang proposed a radical hypothesis. The law of parity conservation, a cornerstone of physics, might not apply to weak nuclear interactions. Testing this theory required experimental evidence, but no one dared to take on the challenge. No one except Chien-Shiung Wu. Wu designed an experiment involving cobalt-60 and conducted it at near absolute zero temperatures. The results were earth-shattering. She proved that parity was not conserved, fundamentally altering our understanding of the universe. This discovery earned Li and Yang the Nobel Prize in Physics. Wu's contribution, however, went unacknowledged by the Nobel Committee, a glaring omission that remains a stain on the history of science. Lessons from Wu's life. Chien-Shiung Wu's story is not just a tale of scientific achievement, it's a masterclass in perseverance and excellence. Here are 5 powerful lessons from her life. Extreme preparation. Wu's meticulous attention to detail set her apart. She double-checked her experiments, built custom tools, and refused to settle for mediocrity. Her thoroughness ensured success where others might have failed. Strategic collaboration. Wu understood the power of alliances. By collaborating with the brightest minds of her time, She positioned herself as an indispensable part of any project she joined. Innovative problem-solving. When conventional methods failed, Wu created new ones. Her ability to think outside the box made her a trailblazer in experimental physics. Focused resilience. Wu didn't let systemic prejudice hold her back. Instead, she focused on excelling in her work, proving her worth through undeniable achievements. Active mentorship. Wu was a passionate advocate for young women in science. She used her position to mentor and inspire the next generation, ensuring her legacy would endure. A legacy ignored. Despite her monumental contributions, Chien-Shiung Wu's name is not as widely recognized as it should be. She was the first woman to receive an honorary doctorate from Princeton University, the first female president of the American Physical Society, and a recipient of the prestigious Wolf Prize in Physics. Her legacy is a testament to the idea that excellence is the best revenge against prejudice. Wu didn't just fight the system, she outperformed it, paving the way for generations of women in science. Chien-Shiung Wu's story is one of brilliance, resilience, and unrelenting determination. Her work saved the Manhattan Project, revolutionized physics, and broke barriers for women in science. Yet her name remains absent from the popular narrative. It's time we change that. Wu's life teaches us that true excellence lies in perseverance, innovation, and lifting others as we rise. If you believe stories like Chien-Shiung Wu's deserve to be told, like this video, subscribe to @CryptoStoic Insights, and share it with your friends. Together, we can shine a light on the hidden heroes of history and give them the recognition they deserve.